Bonjour and welcome to this first video of this tutorial. In this video, we'll finish the 2D script and focus on the coordinate system. So now that we have in 2D an object where the panel behave according that of what we wish, we need to finish it. And to finish it, we will simply need to add the legs because here we can see that the legs cut through the panel. So in order to do this, we can do it in different ways. The first one is to use here the circle to command, which draw a circle using 3 arguments, but we not use the circle. We will use the poly2 command that is the most versatile command for my 2D. You can see in the poly2 underscore description at the end of it that you have a link here. If you click on this link, you can see that it tells me that I have additional status code. In my poly2 here, you can see that I have only one that is written n-1 to end the contour. If here I put 0, for example, and I go into my 2D preview window, you can see now that this edge here is no longer visible. The reason simply because that from here the A0 node to the AB node here, I simply put that I didn't want any visible edge. So if I could and I put back 1 here, you can see that the edge is now back again. So this status can be more than 1 and 0, obviously. And you can see here that, for example, here my points in my script are enter with absolute coordinates, but I can draw them relative to the previous point if it's easier for me. I can draw them with polar coordinates, so with a dimension and an angle. I can also here create center points that will allow me to create curves. And I can even create more than curves. I can also create circles by using a specific 4000 status code. As you can see here, that for this one, I do not have coordinates. I will be using the radius and 360 to create the circle. So here, this is what we will do. Let's go back to our 2D script. And what we will do here is that we will copy paste that poly2 underscore command, and we will simply change its arguments. First one we need is here in the first coordinate is a center point, so 900. And the second one is the radius, so leg radius 360 to indicate a full circle. We will delete the end comma here, and then 4000 plus 1 because here I want to draw the line work. So here I will need to have 4001. It is good, as you will see, to have here the calculation, because sometimes you can have more complicated status code, so it is easier to read 1 plus 2 than to read 3 if you do not know which choice that you made. So here you can see that I have my certain point, my circle. So now I have 2 nodes, and so I will put 2 here. If we go back to our preview pop-up, you can now see that I have a circle here at 0, 0. I could change eventually the origin point of that circle. We have here a parameter that is called leg distance, that is the distance from the leg from the borders. So here what I will do is put leg distance and leg distance. If I go back to my preview, you can now see that my leg is within the panel. Also, you could see that there was a fill in that leg. It is not useful because there is already a fill here. So what we will do is that we will delete the fill by simply put 1. Now, if I go back, there will be no change, but that way we do not generate any kind of fill. So we have a fill on another fill. It will be stupid. So here you can see that it works well, and I can create new legs at the other coordinate points that are needed. But I do not want to do it that way by entering basically the distance directly into the command. My geometry here should be here that I have 0, 0, and then I should be able to move this geometry, this part of the code, to the point where the origin is proper, so my leg is drawn at the correct position. In order to do that, we have to understand the coordinate system in ArchiCAD objects. So basically, there are two coordinate systems in ArchiCAD. A global one where the object lives in its entirety, and a local one that can be moved, stretched, or rotated, and impacts the geometry at the very specific moment that the coordinate system is positioned. So basically, the geometry is relative to the coordinate system at a specific state where the command is written, and the object is relative to the global coordinate system, and it never moves, this one. So how do we change this? Well, in the GDL reference guide, you can look for 2D transformation. And here you can click on the link here, and you will see that in 2D I can translate with the ADD2 command, I can stretch with the mul2 command, and I can rotate with the rot2 command. So we will then use the ADD2 command. If we go back here, I have now the geometry with the origin of my circle at 0, 0. And then what I will do is use ADD2 and the leg distance values for the X and Y transformation. If I go back into my 2D preview here, the result is absolutely the same. But here, the reason why we do this with a bit more lines is because it will be easier for us to create the 3D. But for now, bear with me with these solutions. When it comes to local coordinates, it's possible to delete a transformation, because here the local coordinates impacts everything that is below it. So here I do not have any transformation for my circle, but anything that is below will always start at a new local origin that will be at leg distance in X and Y. So here I need to introduce a new command which is called del, and takes usually one argument, which is the number of transformation that I want to delete starting from the nearest one. So here I want to delete this one, then I put del 1, and that means that now after here this statement, I have reset the position of my local coordinates back to its global position at 0, 0. So here we will finish the legs, and then we will have a look in a more practical way to understand what we are doing with the local coordinates. So what I will do here is copy paste this 3 times with some lines in between like this, and then we will simply position the legs. So the next one will be at A minus the leg distance. The third one will be at A minus the distance, but also at B minus the leg distance. And you can see here I'm doing calculation directly in the command. And the last one will be at here leg distance and B minus leg distance. If I go into my 2D preview, now you can see that all my legs are properly set up. If I change the leg distance value, for example, to 15 centimeters here, you can see now that they are moving properly as they should. Let's also try to change the diameter. And you can see here that my legs are a bit bigger now. So here, let's go back to the coordinate system concept in order to understand it a bit better. So here I will take this brush here, and basically by default the local coordinate system is aligned with the global coordinate system. All of the axes follow the same direction. What we do here, let me go back here with my 2D scripts. Okay. What we do with the first ADD2 command, this one here, we go leg distance here and then leg distance here, which means that when I create the first poly 2, my local coordinate is there. So that's why I can simply use 0 and 0 to the center point of my circle. With the next statement, del1, I go back, I delete that transformation, so I directly go back here. My arrow is on very straight, but the point is that we are now back here. And then for the next statement, I do the same. We go back here, we go here, sorry, and then we go back. And then we do the same for this one, and then this one here. So basically, you can move that local coordinates and then draw the shape that you want. For a simple table, it seems to be overkill, but it is a very important concept because the local coordinate system also exists in 3D. And if you do not understand it at the very beginning of your GDL journey, it will be more complicated to be proficient in it. So here, the last thing that we will do is that we will align our middle of a table with the origin point of the object. In order to do so, we will use the ADD2 command, but simply we will do it way before the other one. And we will move it from minus alpha A minus alpha B. And what we will do at the end is add a del statement. It is very important to have the same number of del that you have transformation. Either they are translation, rotation, or stretching, you need to be neutral when it comes to the transformation stack. So it's almost mandatory so you can have a proper object. So here, let's go back to our preview window. Nothing changed really, except that now we have a bold X at the middle. So we have simply moved of our entire geometry, so the origin point is set up at the middle of it. So that's all for this object. What we will do now is save it and see the results in our project in 2D. And now you can see that in 2D, I have a proper view of my coffee table. So that's all for this video. In the next video, we'll start coding the 3D. See you in the next one.